Hello, my name is Arnaud Delorme, and this is part 8 of a series on independent component analysis applied to EEG time series. This part of us is about removing artifactual components in EEGLAB. And so we've run ICA, so now the next step is to look at the decomposition. And for this, you have the next menu on the list, which is Inspect Label Components by Maps. Depending on the version of EEGLAB you have, this is for the newer versions. The older versions have a slightly different menus, but this one is already in there. So you click on this menu and this is what pops up. So a series of components, and here we have different components. So we're going to go in detail looking at these different components. First, we have eye components, and second, we have muscle components. We also have cardiac components and bad channel components. And finally, we have brain components. So we'll look at all of them except the cardiac components. And so first, let's look at the eye components. So the scalp topography alone here is not enough to really figure out what type of component it is. You have to look at the detail. So when you click on the button here for this component, for example, this is a typical eye blink component. We have the spectrum that's 1/f curve. And then in the component activity, you see the ERP image, we have little dots, and this represents individual blinks. So we can clearly see that this is eye blink components. If we don't want this component to be retained, then we have the little accept button on the bottom, which is green, and we can click on it, and then it toggles to reject. And then this component is labeled for rejection. Here is another eye component. This one is lateral eye movements. Again, so we can see, not as clearly as for the blinks, but we can see in the individual trials some deflection, and this corresponds to eyes that would go left and right. We can also look at the component activity here by going to the plot menu of EEGLAB. And you can see that over half a second you have this deflection, which represents the lateral eye movements. Then we have the muscles. So here, component 10 and 12. And when we look at their properties, we can see the spectrum is very different. You saw the spectrum before was 1/f, and this spectrum has a lot of power in high frequencies. We can also look at the ERP image, and we see it's very noisy. And very often these components are only transiently active during the experiments, so they might only have a set of trial that's very noisy, and then the data goes back to normal. That's a little bit the case for the component on the right, where you can see most of the noise is in the first trials from 0 to 50. Then we have the the single channel components. So these are components which represent bad channels. So the channel went bad at some points, and it's not in all the trials, only a subset of trials. I would usually personally not reject these components, and I would just remove the channels or remove the trials that contain these artifacts, because these channels might still contain some activity that's related to the experiment. So I would prefer to be very conservative and not necessarily remove this channel, rather remove the data corresponding to this channel. So these are the location of the channel and the ERP image. And when we look at the component activation, this, when we scroll component activities, we can see the two types of components here are muscles. So you see there's the very high frequency activity, and we can see the single channel. We can see the trials where it really goes wild, and then on some trials there's no artifacts. So the scrolling the component activity is also useful in figuring out what type of component it is. And then we have brain components. So I've already talked about brain components at length. This one is more occipital alpha. We see the peak at 10 Hertz. So I'm not going to develop too much further on brain components. So you've run ICA, and there is the next menu, which is classify components. So there is a method for automatic classification. That's one of the methods, and this is going to be in the next video. But once you found your components, you might want to remove them from your data. And this is the next menu, remove components from data. You would only do this if you're not going to do group analysis, because when you do group analysis, there's also a method that would automatically remove these components. So it's actually better to just label them and then go to group analysis if you're going to do group analysis, study level analysis. But if you just want to see how the data looks like when you remove the components, you select this menu, remove components from data, and then this interface pops up, and then there's numbers automatically populated here. We have 2. So these are all the components in which we toggle the button from accept to reject. They automatically show up here, and we can decide to remove them. So we press the OK button, and then we have ways to check the data. So first we have a button that's plot ERPs, and these are the ERP before and after component removal. So in red before and in blue after component removal. You can see that sometimes for some channels the ERP, like the one that's circled, is dramatically affected. This is, for example, I channels, because in this specific experiment the subject might have blink just after the stimulus, so the blink dramatically contribute to the ERP, but that might not be representing a cognitive ERP, so it's fine to remove it. You can also plot single trials, so you can see here it's inverted, so in blue it's before rejection, and in red after rejection. This has been fixed in the most recent version of EEGLAB. And here you can see that how ICA removes the blink, and you can see the residual information. So that's very useful to see if ICA did a good job in removing the blink, and you can see if your alpha burst is still there, and this kind of information. Once you're happy with the components that were rejected, you can accept, and these components would actually be removed from the data. So thank you for your attention, and I'll see you in the next video.